Unit 4.3 Modeling with Quadratic Functions. So the objective of this class is to model data with quadratic functions. Whenever you see the word modeling, that means we applied all the numbers in a real-world context. Before we start doing that, we have to learn the concept of writing an equation of a parabola based on 3 points. If you still remember, when we try to construct a line, we need 2 points. But when we try to construct a parabola, we need at least 3 points. So 3 points control a parabola. Here's the example. So you're given 3 points. They are 0, 0, -1, -2, and 1, 6. The question is, what is the equation of this parabola which pass through these 3 points in standard form? Since in the standard form ax squared plus bx plus c, we have 3 variables, a, b, and c. X, y is only the input and the output. So in order to find that particular equation of parabola, we need to solve for a, b, and c. Since we have 3 variables, we need 3 equations to solve for these 3 variables. Based on these 3 points, we can set up 3 different equations right here. All we need to do, just plug the value of x, in this case 0 right here, the value of y right here, all the x go right here, then we can set up 3 equations. Same here, we just substitute all the x with -1 right here and put -2 as the y value here. Same here, 1 go to here, go to the x, and 6 go to the y. Once you did that, you just simplify, and then you have 3 equations. Equation 1 right here, equation 2 right here, and equations right here. Now that you have 3 equations, you can just go back to the concept you learned last time to solve for 3 variables. In this case, we use elimination, and then we can solve a, b, and c. Once we got that, a equal to 2, b equal to 4, and c equal to 0, we can plug all these variables back to the equation. Remember, this is the standard form, y equal to ax squared plus bx plus c. And since we got a equal to 2, b equal to 4, c equal to 0, and here we are. This is our equations of the parabola that we are looking for. And all these 3 points are the points that this parabola will pass through. Now let's apply the quadratic function in a real-world context. In this example, there are some campers. They are launching 2 rockets in their camp, and the path of the rocket 1 is based on a quadratic function model. Look at this. We know it's quadratic because they have an exponent of 2, where t is time in seconds and h is the distance from the ground. So if we try to graph it, you're going to have something like that. Instead of x, this time we use t. Instead of y, this time we use h stands for distance, t stands for the time. We are talking about the rocket 1, follow a parabola, something like this. This is rocket 1. And the function for this parabola is h equal to -16 t squared plus 150 t plus 1. I find it interesting because, even in time 0, since c is equal to 1, there's still 1 feet above the ground in time 0. Anyway, if you cannot recognize the form, it's always in the standard form right here like this. Ax squared plus bx plus c. So c equal to 1, which is the y-intercept I just talked about. B is 150 and a is -16. According to the formula, we know the vertex right here is negative b over 2a, and the y coordinate of this vertex is f of negative b over 2a. We learned this concept in the previous sections. Okay, so let's find out what they are. So in this case, because it's t, I don't use xy anymore. So I will write down t is right here for the vertex. The x coordinate of the vertex is t, and the y coordinate of the vertex is going to be h this time. But remember, they're xy basically, just using different names for the variables. So right now, let's find out what t is, the x coordinate of the vertex. Let me write down the x coordinate of the vertex. So based on the arithmetic here, we have equal to negative b over 2a, which is negative b is 150, 2a, a is negative 16. So we end up getting 4.7, which is t. To find h, all we need to do is plug in the value of t, which is 4.7, back to the original equation we have here, because h is equal to negative 16. Now we know the value of t, we should plug in t right here, 4.7 squared plus 150 times 4.7. T is equal to 4.7 as the vertex plus 1. And if you do a little bit arithmetic, h is equal to 352.6. Right now we know h is 352.6 and t is 4.7. So the vertex here is 4.7 and 352.6. The maximum height that the rocket run will reach is 552.6. Now that we know the maximum height of rocket run is 352.6 feet, in order to decide which rocket flew higher, we have to find out the maximum height of the rocket 2 can reach. For rocket 1, based on the math that we just did, we can roughly sketch the graph is like this. The y-intercept is 1. The vertex is right here, which is 4.7 and 352.6. For rocket 2, the question didn't really give us the exact equation. They just tell us it is modeled by the graph like this. Based on the graph, we can actually determine the x-coordinate of the vertex by adding these 2 points and then divided by 2, which is 0 plus 12 divided by 2, which equals 6. Because we know the line of symmetry will pass through the x-coordinate of the vertex. In the line of symmetry, we divide the parabola into exactly equal halves. So once we know the x-coordinate of the vertex is 6 right here, we can just estimate the height that you can reach based on the graph is 580. That's why it said approximate maximum height here. Since the height of the rocket 2 that can reach is about 580 square feet, we conclude rocket 2 flew higher than rocket 1 because the maximum height of rocket 1 is only 552.6 feet. The last concept that we are going to learn in this unit is using quadratic regression. In the next 2 slides, I'm going to show you the concept of what quadratic regression is all about. Then I'm going to make another calculator video clip so that you know how to use the calculator to come up with the model based on the concept of quadratic regression. So in this case, they give you the tables right here, which shows a meteorologist's predicted temperatures. First thing first, you have to understand we are talking about two variables here. The time here, we call it an independent variable, and the temperatures here, we call it dependent variable, because the temperature is dependent on the time. In different time, you have different temperature. So when you enter the data into your graphing calculator, L1 is the x, which is the independent variable, and in this case, it is the time. And L2 is the dependent variable, which is the y, and in this case, it is the predicted temperature. But be really careful when you enter the data right here. After 12 p.m., like 2 p.m., they enter 14 instead of 2, because they're using the 24-hour clock to represent the time afternoon. After you enter all this data, you use the quadratic regression feature in your calculator, then they generate the quadratic model for you. So here's the quadratic model, which is a standard form, and the values of the variables of A, B, and C are right here. So that's why you have this quadratic function by substitute A, B, and C with the values given to you from your calculator. So if you graph it, you're going to have a quadratic model like this. These are the exact points. For example, when you say 14, this is 14 right here, and this is around, say, 78 right here. You'll notice all these points are not exactly falling onto the graph because it is the best fit curve based on this data. Now that we have the quadratic model, we can use it to predict the high temperature for the day. All we need to do is to use the maximum features of your calculator, or just use the table functions. By using the maximum feature of your calculator, they give you an estimate maximum right here, which is 15.69 for the x value and 79.37 for the y value. Remember, y is the temperature and x is the time. You can also use the table functions to predict the high temperature for the day. By looking at the tables, you see y value is increasing up to 79.379. After that point, y is decreasing, and that's why this is the maximum value of y when x is 15.7. 15.7 is on a scale of 24 hours. So if you want to know exactly what time is 15.7 referred to, you have to convert this number back to the actual time. So 15 hour means 3 p.m. and 0.7 hour here, if you change it back to minutes, all you need to do just times 0.7 hour by 60 minutes, and then it'll give you 42 minutes. The exact time for the maximum temperature for the day is 3:42 p.m. and the maximum temperatures is around 79.4 Fahrenheit. In the following clip, I'm going to show you how to use TI-84 to model quadratic functions. Press Stat, select Edit. Then if you have some data there, just clear it out by using the arrow key, clear, enter, and then you can start entering your data. After you entering all the data, hit Stat, Cal, move down to 5, quadratic regression, enter, and then keep entering until they do the calculation for you. Now you want to plot the graph by doing second, Stat, plot, turn on the plot graph by hitting the enter button when the on is blinking. Then hit second, quit. Before you plot the graph, you set the window by doing graph, zoom, scroll down to 9, hit enter. Now you have the graph of the 6 data you entered. To see the continuous graph, you have to hit y equal, then you have to enter the equations, of course with the values of the variables a, b, and c. So you just enter the equation, then hit graph. Now you got a curve. Once you have the graph, you can hit second, cal, and use the maximum features to find the maximum points. It will ask you left bound, you click yes, and then you use the arrow key to pass through the maximum point. You don't know exactly where's the maximum point, but just eyeballing it, and then move beyond that, and then hit enter. They ask you to guess, hit enter again, then they will give you the maximum. Or you can use the table function to find the max by hitting second, table. You have to set the table correctly so you can see the max. Let's hit second, table set, and then we can set the table starting with 8 and change the independent variable to auto, hit enter, then second, table. Now we got another table. When you scroll down, you will find out the maximums gonna lie between 16 and 17. So we have to change the setup again. I change 13 to 15. Then the change is gonna be 0.1 instead of 1. I use the second table function again, and then I see the maximum is gonna be at 15.7.